Okay, this video is about scientific notation. Scientific notation is a way to write very, very big numbers or very, very tiny decimals in an easier fashion. So at the top of our page, we have an example of what scientific notation looks like. Okay, it's going to look like a decimal, okay, and our decimal is going to be between 1 and 10. So this number has to be bigger than 1, but also less than 10. Okay. And it always is followed by some multiplied by some power of 10. Okay. If it's a positive exponent, that means we are dealing with a big number. If it is a negative exponent, it means we are dealing with a teeny tiny decimal. Okay. So those are the general steps. So here we are going to go from standard form, which is our typical way we write numbers, to scientific notation. Okay. So we are going to, in our big numbers here, we're going to place a decimal in a spot that creates that number that's bigger than 1 and less than 10. Okay. Really key to doing this is to just place it after the first number. Okay. At least with our big numbers here. Okay. So I'm going to put the decimal right here between the 2 and the 6, because that would give me 2.685. And when I'm writing my number, I get rid of all those decimals all those zeros at the end. Because technically, okay, I could write them, but because they're in a decimal now, I don't need them. So that's why this kind of condenses our numbers a little bit, makes it a little bit easier to work with. So I'm going to say 2.685. Okay, I include any of the digits before that string of zeros at the end. Okay. And then we are going to say times 10 to a certain power. Now it's going to be a positive exponent because it's a big number. And essentially we're saying how many decimal places did we now just throw in here? So remember that in a whole number, there's an invisible decimal at the end of the number. We just don't write it. So if I've now placed my decimal here, I can kind of just count how many spaces there are. So 1, 2, 3, 4, 5, 6, 7. Okay, so I have now moved that decimal 7 spots. So this is going to be 2.685 times 10 to the 7. Okay. My next one, I'm going to put the decimal right here. So 3.1459. I use all my digits until I get to the string of zeros. I keep saying string of decimals, string of zeros. Okay, and now it's going to be times 10 to some positive exponent. How many? Well, okay, how many spots until I get to the end? Here it's nice because they're in groups of 3. So 3, 6, 9. Okay, so this is going to be 3.1459 times 10 to the 9th power. And then my last one on this row, I'm going to put the decimal there. So that's 9.7. And it was 1, 2, 3, 4, 5. So 9.7 times 10 to the 5th power. I'm going to throw one more in here, okay, because I just thought of it now. So I'm going to say 41030000. We'll do that. Okay. And the reason I did this is because when we put our new decimal here, okay, it's going to be 4.103. So I have to include that 0 that's here because it's not in that full string of zeros at the end of my number. So in this case, it's still going to be 4.103. Okay. Then I can get rid of all those zeros at the end. And if my decimal is here, it's 1, 2, 3, 4, 5, 6, 7. So 4.103 times 10 to the 7th. So I'm not saying to stop when you immediately see a 0. Okay. It's when you see that string of zeros that you don't have to include those anymore. Okay. Here we have decimals. So when we do our power of 10, it's going to be a negative exponent. Okay. So here we see the decimal point, okay, where it is already. We're going to move that decimal point to once again create that number between 1 and 10. Okay, so our new decimal point is going to be right there. So that'd be 2.1. And then we say how many spots it was moved. So 1, 2, 3, 4, 5. So 2.1 times 10 to the negative fifth. Okay, tiny decimals, negative exponent. The next one, we're going to put the decimal here after the 3. So 3.89 times 10. And we see how many spots it was moved. 1, 2, 3, 4, 5, 6, 10 to the negative 6. When you're doing standard to scientific, honestly, it doesn't matter which direction you're going, okay, because you're just counting the spots that it changed from. When we do the next section, which is going from scientific notation to standard form, that is when it's super important to know which direction you have to move the decimal. But for this, we're just finding like, how many decimal places did it change by? So it doesn't really matter if you're going left to right or right to left here. Okay. And then our last one, a very, very tiny decimal. I'm going to put my decimal point here between the 6 and the 7. So this would be 6.783. And then we got to move it 1, 2, 3, 4, 5, 6, 7, 8, 9. Sometimes the numbers blend together. So this would be times 10 to the negative 9th power. Okay, so that's going from standard to scientific. I can also ask you to go backwards. So I can give you scientific notation and I can ask you to write it in standard form, like write it as a normal number. Okay. And once again, you're looking to see, do I have a positive exponent? Because that means I'm turning this into a big number. Or is it a negative exponent where I'm going to be sliding the decimal so it ends up looking like a tiny decimal? Okay. So the first one is 6.13 times 10 to the fifth. This is going to be a big number. When it's a big number, I'm going to slide decimal to the right to make it a bigger number. So I like to rewrite my decimal to start so I have more room to work with. And now I need to move that decimal 5 spots. And like I said, we're making it bigger. So 5 places to the right. So I already have decimals or numbers here. So that's 2 places. I need to go 3 more. And when we have this, we have to fill in those places with those zeros. Okay. And I rewrite my final answer because that is messy to me. Okay. And I don't want it to be confusing and possibly look like there's 2 decimals in the same number because that wouldn't be correct. So I like to, if I'm doing the loop-de-loops, that's fine, but I rewrite my final answer. So this one should be 613,000. I'm going to go down to the next one below it. This is also a positive exponent, so it's going to be a big number. So I'm going to rewrite my decimal 4.289, but now I'm moving it 8 spots to the right. So 1, 2, 3, 4, 5, 6, 7, 8, and I'm filling those in with zeros. So this is going to be 4289 00000. And then to make life easier for whoever is reading it, I'm going to make sure I put in those commas every third from the back so I can see what number this is. So this was really 428,900,000. Okay, the next one, we have 10 to the negative 6. So this is a tiny decimal. Okay, so when we have our negative exponent, okay, this is a tiny decimal. We're going to move decimal to the left. So here is my 3.89. Notice I gave myself a little bit more room on the other side now. And I'm going to move that decimal 6 spots to the left because of the negative 6. So 1, 2, 3, 4, 5, 6. This becomes my new decimal. And once again, we just throw in those extra zeros as needed. And now this is where I definitely need to rewrite it because I have 2 decimal points in my number, which is not good. So this is 0. If you don't put the 0 at the beginning, it's not the end of the world, but 0.0000389. Okay, and our last one of that section. Okay, I am rewriting my 2.1. It is 10 to the negative 5th. So I'm going 5 to the left to make it smaller, to make it a tiny decimal. So 1, 2, 3, 4, 5. This is my new decimal point. Fill these in with zeros. I get 0.00021. Okay, and the last section, this is just things that you might see on a calculator. So it's good to know how to read it. And I don't know if you've ever encountered this and you're like, what the heck is this E on my calculator? That is just the calculator's way of doing scientific notation. Okay, because maybe you type something in, you got like a really, really big number and it couldn't fit on there. Okay, and so it would use this E. So that E is really just taking the place of the times 10. Okay, so here 3.5 E15 is really saying 3.5 times 10 to the 15th power. And if I wrote that out, okay, moving over the decimal once would be one spot. I would need 14 extra zeros to get 10 to the 15th. So 3, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that should be, I'm just double checking to make sure that was 15 spaces. Yes. So now I'm going to put those in and you can see how large that number actually is that they tried to write on the calculator. And then our other one, I see -9. So this is going to be 8 times 10 to the -9th power. Okay, which means I would move my invisible, if I put here, my decimal is here, I would move it once. And then I want to move it 9, I have to move it 8 more times. So I need 8 zeros. And there's kind of a shortcut you can do here like I am. So 0.00000008. And that is our answer for that one. Okay, so hopefully this isn't too bad. We're going to do some practice, but just remember positive exponent, big number, negative exponent, tiny decimal.